Welcome, and thank you for joining this webinar, Advancing Quantum Communication, Role, Impact, and Technical Foundations of Quantum Technologies in 6G and Beyond, prepared by Alpert Research Team. Quantum communication is transitioning from academic theory to strategic infrastructure. This webinar explains how physics, not math, can guarantee trust, and how quantum systems integrate realistically into modern communication networks. Our mission today is to take this incredibly complex world of quantum communication, or QC, and really perform a strategic assessment.
We want to look at how it's actually moving out of the lab.
And into the core of our next-generation wireless infrastructure. We're going to be looking at its integration, its impact, the challenges, and of course, the massive opportunities within 5G advanced and, looking ahead, 6G systems. What's truly fascinating here, and really what drives the enormous investment, is the strategic imperative. We are witnessing the slow-motion collapse of classical digital security. This deep dive is really about shifting our reliance for security away from complex mathematical assumptions, which can always theoretically be broken to a completely new paradigm.
One based on the unbreakable laws of physics.
That is the fundamental existential shift. This is where the threat model changes dramatically for everyone in the wireless and security space.
Quantum computers, because they use principles like superposition and entanglement, can solve certain problems exponentially faster than their classical counterparts.
And one of those problems is factoring large numbers.
The most critical one. They pose a devastating threat to our existing public key crypto systems. Okay, so to make this tangible, let's contrast the mechanics. We know classical ciphers are about scrambling and unscrambling data with shared keys.
Right, think about the progression. You had the Enigma machine, which used simple substitution logic made incredibly complex by mechanical rotors, a plug board, a reflector. The key was the machine's specific configuration for the day.
And now we have modern ciphers, like AES, the Advanced Encryption Standard,
which use vastly more complex mathematical rounds, subbytes, shift rows, mixed columns, to create this avalanche effect of changes based on the key. But even AES, the workhorse of global security, isn't immune to theoretical threats. We're talking about algebraic attacks, things that try to represent the key as a massive system of equations. If someone can solve those efficiently, AES collapses.
The ability of a quantum computer, using something called Shor's algorithm, to efficiently factor those huge numbers means that the foundation protecting everything from global finance to government data is rendered instantly obsolete.
The moment a large-scale, fault-tolerant quantum computer is built.
But the threat isn't immediate, right? We don't have some massive fault-tolerant quantum computer sitting in a basement somewhere.
That's the key point. The vulnerability is present, but the capacity to exploit it is not yet. And this leads to what we call the harvest now, decrypt later problem. Think about sensitive data, anything that needs to stay secret for a long time. That data is encrypted today and sent over a classical network. An adversary could just scoop all of it up, store it indefinitely, and then decrypt it the moment a sufficiently powerful quantum computer arrives.
So it transforms the security problem from a technical hurdle today into a massive strategic risk management failure down the road.
The message is crystal clear. The integration of quantum systems into our network architecture is happening now, not in some distant theoretical future. We've established that quantum communication will not replace classical wireless networks, but it will redefine how trust, security, and optimization are built into 5G advanced and 6G systems.
Interested in gaining a deeper understanding of the transformative power of wireless technology? Join the Alpert Research Team's webinars to explore cutting-edge wireless innovations, their applications, and their implications. Click the links below to learn more.